Yeah.
I thought you had become a metallurgist.
No, not at all, sir. No, because we are able to connect now easily and figure
Right,
out
right.
how it is.
I think sir will begin now.
Yes, sir. Yes, sir.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream.
My screen is visible, sir?
Not yet. It's only the video screen at the moment.
You need to close that and start.
Yes, sir.
Right.
Now visible, sir?
Yes, yes.
Thank you, sir. A warm welcome to all the students. A warm welcome to all the speakers for today's session. As a continuous effort on behalf of Dayanand Sagar University, we are bringing in a lot of key professionals from the industry as well as senior academicians from Dayanand Sagar University to give an exposure to the students, especially from the second PU or the 12th standard, who have recently, with the news of the examinations being postponed, are worried what kind of careers, what kind of programs, what kind of career choices. So today we take the opportunity of taking you with the careers in mechanical engineering with new age specializations. This is something which is very important today, with new age specializations and the way forward. So we're going to talk about mechanical engineering per se, with the specializations like robotics and automation, the additive manufacturing, and electric and hybrid vehicles. We see this, but we are not aware how to get into this. So here's the opportunity for all the aspiring students to hear the best of the best from the industry speakers as well as the senior academicians who create, manage, run, and create outputs for this program at DSU. So warm welcome to all the speakers for today's event. I take this opportunity of welcoming our Honorable Vice Chancellor, Dr. K.N.B. Murthy sir. He's a professor of computer science engineering and the Vice Chancellor at Dayanand Sagar University. Sir has also been the former Vice Chancellor at PES University, Bangalore. Sir holds a bachelor's degree in electrical power engineering, master's degree in electrical engineering from Indian Institute of Science, and PhD in computer science and engineering from IIT Madras. Sir has worked as a research specialist in parallel computing at New Mexico State University, USA. Sir is currently a member of Karnataka State Higher Education Council, also the chairman for Board of IT Education Standards, Government of Karnataka Initiative, as well as the chairman for Ranganath Center for Information Studies. and the Academic Senate for the prestigious IIIT Dharwad. A warm welcome to you, sir.
Thank you, Shinde.
The second speaker for the day is the and the most liked person who's always been a part of us from the industry is Mr. Arvind Srinivas. Sir has over 36 years of experience in the IT industry through TCS, working across different stages of IT software lifecycle in different industry domains such as banking, finance, insurance, education, as well as manufacturing. He has worked in different roles, starting as a junior programmer, analyst, progressing to heading a multi-country account or unit product head before being a part of a group level initiative of business excellence, interacting with aerospace, manufacturing, retail, IT, research, hospitality, and chemical companies in the Tata Group. A warm welcome to you, sir. Our next speaker for the day is Dr. M.S. Rajgopal. Sir has graduated from UBC in 1981 with a distinction from Bangalore University and was a rank student. He obtained MTech in Thermal Sciences from IIT Madras and started his industrial career at Kirloskar Electric for 15 years. He was heading the R&D mechanical group and responsible for development of new age motors and generators. During his tenure, he completed PhD at IIT Madras. Subsequently, he joined NIIT to head their MCAD Engineering Services Division. Later, he assumed leadership role as a program manager, Advanced Mechanical Engineering Group at Jack Welch, General Electric Research Center. He also worked as a practice head for geometric software before switching over to academics and worked with prestigious institutions like PESIT, BMSIT, Oxford College, and so on. Presently, he is heading the Department of Mechanical Engineering at Dayanand Sagar University. Overall, he has 18 years of academic and research experience besides 20 years in the industry in various departments, including production, design, research, and development. A warm welcome to you, sir.
Thank you. Thank you, Mr. Shinde, sir. Thank you.
The speaker number 4 for today is Dr. K. Ramchandra. He is a leading aerospace and mechanical engineering consultant, a chartered mechanical engineer, and was the director of the gas turbine research establishment under DRDO of the Government of India. He has over 35 years of R&D experience and 8 years of teaching and training experience. He steered the Aero Engine Kaveri for the Light Combat Aircraft LCA with a project outlay of over rupees 3,000 crores. Under his leadership, many major certification test facilities required for certification of aero engines were set up in the country. He has initiated several ongoing gas turbine technologies required for the 5th generation aero engines. He has launched a major initiative of unmanned mini underwater vehicles, amphibians, unmanned ground robots, aerostats, and water surface vehicles for agriculture applications and disaster management. A warm welcome to you, sir.
Thank you. Thank you, Srinivas. Thank you.
Our
very
speaker
much.
number 5, also from an industry practitioner, is Mr. Pankaj Bande. He is the Chief Technology Officer at Wiz Club. He has worked previously as a Senior Manager Projects, leading the DTO Garage for EAS in Cognizant Technology, and as a Senior Architect as part of IoT Solutions Engineering Group in the IES department of Wipro. A dedicated, resourceful, innovative professional offering an extensive experience of about 20 years in the area of IoT, artificial intelligence, digital voice assistants, chatbots, embedded systems, and mobile robotics, both in hardware and in software. Having used his skills in research and development, product design, education industry as an entrepreneur, he is a mentor by choice and derives extreme contentment in helping people build capability. He likes to ideate and innovate advanced technology solutions and specialize in the following through the projects. He likes to make teamwork engaging and interesting while not losing sight of measurement of returns on investment. He comes with a high degree of discipline and involvement and like to build self-sustainable people system. A warm welcome to you, Mr. Pankaj. Our next speaker for the day is Dr. Sharat Kumar Warrier. He has over 22 years of experience in various engineering organizations, including Quest Global, where he was the competency development head. He had the opportunity to get exposure to multiple major organizations, including General Electric, Airbus, Rolls-Royce, Pratt & Whitney, and GTRE. He was most recently leading the continuous improvement and technical training functions for Collins Aerospace India, a Raytheon Technologies company. And alumnus of Government Engineering College, Thrissur, he has MTech and PhD in Mechanical Engineering from IIT Madras. A warm welcome to you, Dr. Sharat Kumar.
Thank you, Mr. Srinivas.
And finally, our speaker number 7 for the day, very important, rightly pointed out by all our student crowd today that they want to know about placements. So here we'd like to introduce Mr. M.N. Guru Venkatesh. He is the Vice President Placement and Skill Development Center at Dayanand Sagar Institutions. He has done his BE in Computer Science and Engineering and with an MBA and over 20 years of experience in training and placements. He has facilitated to provide job offers to more than 20,000 students till date. He is a member of the World Skills International WSI Netherlands. He's represented India in the category of IT software solutions for business as an expert cum jury for World Skills competition held at Canada and also World Skills competition held at London. He's worked as a jury for national team selection, World Skills Germany for the competitions held at New Delhi in association with NSDC and NASCOM. A warm welcome to you, sir.
Thank you, sir. Thank you so much.
So we now move to the first speaker of the day. Would like to invite Honorable Vice Chancellor Dr. K.N.B. Murthy for setting the context and sharing his views. Over to you, sir.
Thank you, Srinivas Shinde. Respected panelists who are experts in the domain of mechanical engineering. Also, the students and the parents who have joined this webinar cum campus info session on a Saturday evening. I'm extremely happy and also elated to be a part of this session. Dayanand Sagar University has been trying to provide information to the students and the parents with regard to the various programs of study, the career choices, and also give enough information to make a informed decision to take up the higher studies in the years to come. This is a focused effort because that's the reason why we are trying to organize info sessions for various streams of engineering and other programs of study, inviting experts to tell us about the kind of developments, the kind of future of work that we see. I am extremely happy that we are all here for about next 60 to 70 minutes to understand the entire scenario. Let me begin by saying that now the pandemic and more or less the board examinations are resolved now. I think pandemic is also coming to a close, maybe in the next 2 to 3 months, everything will be under control. We are also, I think you and we are happy that the board exams have been resolved by cancellation of the +2 examination both at the central level and the state government level. The next thing that is left out for you and all of us to think over, what should be the program of study, which university or institute to join, and to make an informed choice. Quite often since I'm the Vice Chancellor, I keep getting one question from all the parents and the students: which course and which institute to join, and which is more important? Honestly, both are not important. You are important. You need to decide what you want to do and what you are interested in. I think probably you can pursue that program of study. Once you are having the passion, I'm sure you're going to do well in whatever program that you're going to choose, in whatever institute that you're going to study. In the present day context, in the last few years, we have been seeing tremendous changes in every walk of life. Every walk of life, we see lots of changes, including the higher education. When I look at that, I think the statements made by Albert Einstein long back are still applicable. Two statements he has made. I think two are there. He has made many statements, but two seem to be very important for us. One that he says is that training of mind to think is more important than learning of facts. If you remember something, it's not enough, but you need to train your mind to think. That's critical in the present day context. The second statement that he has made was, whatever you learned or whatever that remains after the school is what matters. Means whatever you are going to understand after the school, once you have completed your degree, that's what matters. Therefore, these are relevant in the present day context. I'm extremely happy to tell you a few things that have happened, or few predictions that have been made about the future of work, about the future. Several organizations like the McKinsey, Deloitte, Harvard Business Review, the MIT Technical Review, World Economic Forum, the World Business Council for Sustainable Development, everybody has said 3 or 4 important things what the future is going to be. The first, they said, future of work will go through complex disruptions. There will be a lot of changes because there's a rapid technology evolution. In other words, technology will get into every walk of life. Therefore, because of that, there will be a lot of disruptions. Second, the kind of work environment that we see in the future is far different from what we see today, because several of the existing jobs may not be present in the next few years. The existing jobs will completely be done by the automation, where a new set of jobs are going to come in. And it's also being said technology will dominate the future, and it's going to be great number of opportunities in every field of study, whatever study that you're going to do, irrespective of the field of study, be it engineering, mechanical engineering, or aerospace engineering, or management, or BSc, anything that you're going to take, there are plenty of opportunities are going to be present. Then what is required to get those opportunities, to encash those opportunities? Several things are required. One, you need to acquire new age skills, newer skills, meaning the skills which are different from what we normally do. One is the analytical reasoning becomes very, very critical. Second, problem solving skills become critical. Reflective judgment becomes critical. Research and inquiry skills, inquiry basically investigative kind of thing, questioning becomes very, very important. Digital literacy becomes very, very critical. And therefore, the kind of skills that are required for the future are far different from the kind of skills that we are seeing today. Where the jobs are going to be? Jobs are going to be there in every field, involving some of the things which I am going to mention here are healthcare sector. Healthcare sector is one area where a lot of jobs are going to be created. The second, safe and faster mobility, the transportation sector is another area where a lot of jobs are going to be created. Then the third area which is going to see lots of jobs are going to be connectivity, the 5G connectivity, etc. Then the computing power is called nothing but the quantum computing and other things will reduce lots of jobs. Financial technology, fintech technology is going to be highly thing. Then the other area where a lot of things are going to be done is the digital twin. Digital twin is basically creating a simulated model of an environment. For example, if you think of an automobile, you have a digital twin for the automobile, and it gives you the exact thing that can happen in the automobile through a computer simulation. That's the digital twin. Then the climate change. Climate change is another area where a lot of jobs are going to be created. Then faster construction technologies is another area where lots of jobs are going to be there. Meaning mechanical engineering is going to be involved in everything that I mentioned. For example, you take healthcare. The healthcare instrumentation, the kind of instrumentation that we use for healthcare have to be designed and manufactured by the mechanical engineers. You take 5G connectivity. When we have to provide the 5G connectivity, good amount of hardware and other things have to be designed, have to be manufactured by mechanical engineers. When you say quantum computing, the computers, the material that are used, the parts that are used are going to be mechanical in nature. And everything that we're going to talk about is going to be mechanical, is going to be around mechanical engineering. There are 3 paradigm shifts that we are going to see going forward. One, the context-based curriculum. The curriculum will be far different from what we teach today. Future, we need to teach only those things which are relevant. That's one change that we need to make. Second, the kind of examination that we're going to conduct in the future will be far different from the kind of examination that we are doing today. In other words, intelligence-driven assignments or assessments are going to be the order of the day. The examinations will have all kinds of changes that you're going to see. The third change or paradigm shift that you're going to see is connecting the concepts. Means transdisciplinarity or multidisciplinarity becomes very, very important. Because if you know mechanical engineering, that's not enough. You need to know computer science, electronics, mechanical, civil, and also you need to know something about general subjects like biology, some subjects like philosophy, because these things are going to be interconnected in the future. In other words, you need to see whether a concept of biology can be used in mechanical engineering is going to be the key. Therefore, any university which incorporates these kinds of things, which are going to impart the kind of skills that I mentioned, are the universities which you need to look for. I'm extremely happy to inform Dayanand Sagar University is aware of all these requirements. Therefore, it's going to put its best efforts to ensure that the paradigm shift changes are going to be taken, and the students who join Dayanand Sagar University will get the best quality education in the years to come. The last thing that I would like to assure you, apart from the curriculum, the academics, there'll be enough scope for the extracurricular activities also at Dayanand Sagar University. I'm sure the experts will tell you more about the specialized technologies, the amount of scope that's there for mechanical engineering and the new age kind of things. And with these few words, I thank the organizers for inviting me to be a part of this, and also wish each one of you best of luck and choose the best career where you have the passion, what you like most. Doesn't matter about the other context, because jobs are there for every program of study that we want to take it up. Thank you. Thank you very much.
Thank you so much, sir. We would now like to take the opportunity of inviting Mr. Arvind Srinivas, and he would be speaking on the topic, why engineering? Many students have written to us. Please give us some thoughts. So here is the answer to it. Over to you, sir.
Can you hear me, Shinde?
Yes, sir.
Yeah, is my screen visible?
Yes, sir.
Yeah, thank you. Respected Vice Chancellor and other senior colleagues in this panel, a warm welcome to the pre-university and the 12th standard students and their parents who may have logged in. my session here is primarily to talk about those people who may be wondering as to whether engineering is a career or not. I'm not going to be talking anything specific on any career, but I'm just trying to pitch in for engineering as a career. So what I want you to do is, especially students, you must have seen this Underdog movie, just follow your dreams. There's nothing wrong in that. And develop a passion for your chosen program of study. Fuel your passion, because most people are happiest when they tap into their passion. And passion gives life a form of fulfilling its own intention, and it leads to purpose. Play to your strengths, talents, and gifts. Celebrate your successes, both big and small. It has been said that the most certain way to bring value, meaning, and joy to your life is to connect with and bring value, meaning, and joy to the lives of others. So the more you give, the more you get back. So if you want to do anything for the community and the people around you, for your family, for yourselves and your society and all that, then definitely this is something what you should be interested in. So if your passion is problem solving, then definitely look at this Rubik Cube. If you're interested in getting this solution for this Rubik Cube, definitely you are here for the right choice of program of study, which is called engineering. What does engineering do? Engineering is primarily to fix some broken problems, because there are either opportunities for something which is very new or something which is already broken and been fixed. And as the Vice Chancellor said earlier, he was quoting Einstein, where he was saying that the training of the mind is to think more than the actual fact obtained. And that's exactly what engineering does. In fact, scientists tend to explore the natural world and discover new things about the universe and how it works. Whereas an engineer applies that knowledge learned in order to solve practical problems, often focusing on cost, efficiency, and other limits. Scientists observe the world, while engineers focus on creating it. And that's where thinking matters. The modern era we live would not have been possible without the marvels of engineering, as the Honorable Vice Chancellor mentioned earlier, whether it be a microchip or high-speed vehicles or the mobile networks or automated cars or electric vehicles, whatever you see right now, or even these automated assembly lines. In fact, scientists generally investigate that is already present, but engineers tend to create which has never been there before. So it's actually a science to describe electromagnetic radiation, which you must have studied in the 12th standard. But it's actually engineering to build a radio or a television. Many of the so-called wonders of modern science are actually wonders of modern engineering. I'm sure you would have involved, you would love to get involved in engineering for safer, faster, fuel-efficient vehicles, motorcycles, and things like that, or probably create smaller smartphones that are easier to use and things like that. If you have a passion, then the problem is here. This is typically what an engineer does. The engineer typically tries to identify what the problem, and then plan that the solutions are possibly like this, and then execute what are the possible solutions and figure out which is the right way. Then verify that the solution is actually working, and then confirm that it has been solved by going to the field. But then the problem that is solved does not mean that it's resolved, because after a period of time it becomes stale and there are more requirements and you will have to improve. So you constantly improve after the solution has become stale and some more new requirements have come in. And again, you start improving to identify certain new incremental problems and keep going on this. So this is typically how a continuous cycle of engineering keeps going. Given this, I just thought I should talk a little bit about what we heard earlier in terms of trying to invoke a spirit of inquiry for typical engineers. If you have some curiosity, then definitely this is where you should actually be. In fact, you see the word called heuristics and the spirit of inquiry. Heuristics is nothing but a simple set of rules are inculcated by evolutionary processes that explain how people make decisions, come to judgments, and solve problems practically when facing complex problems or incomplete information, which is the case many a time. Examples of this method are what we call as rule of thumb, or an educated guess, or intuitive judgment, guess estimate, or common sense in daily life. Imagine if someone from a recipe from memory is cooking and does a quick bit of estimating, they know exactly the amount of salt and other spices to be putting in. And this is nothing but a heuristic. And a lot of aphorisms such as measure twice, cut once are part of the game. Or probably if you have seen a sweet old woman who might remind you of your grandmother, you might immediately assume that she is kind, gentle, and trustworthy. That's exactly what heuristics about. So we stoke your curiosity, to know about things and enable the spirit of inquiry. Look at this. This is a standard cycle, which probably most of you would have used, or probably at least in the younger age. The pedal and the gear. This is nothing but a standard cycle. But then if you're more interested to know about this, this is exactly where engineering comes. Or look at this in terms of the lever gear. This is typically a fan, a table fan, which some of you must be using. And this is typically how you can see the transparent gear, which you see the lever gear, which actually makes the fan rotate. That's nothing but engineering. But actually, we miss out on many of these day-to-day common things of engineering. Or look at this. This is nothing but a worm gear, which is used for as a tuning mechanism, including your guitars, mandolin, and things like that. See this example over here. Look at this. This is an example of a car steering, where the car steering actually is being used to turn the front wheels either to the left or to the right, depending on how you would like to do that. This is, if you're interested to know how these things work, then engineering is the right discipline for you. There is very interesting things to find out, because these things have been existing for a while, and we believe that there is something which invokes curiosity in our minds. Given this, I also thought I should also show you a small picture of how these automated assembly lines, which were mentioned earlier. Look at this. If you're interested in working in these kind of shop floors, then this is exactly where you need to look at engineering. Or if you're looking at this situation over here, where you have a remote control with a robot, where you would like to have your dog playing around tricks and all that, then you can actually build some of these things in engineering and get your curiosity filled. I'm sure you would have seen it from some of your friends or probably seen it in movies. But if you want to do it for yourself, you can actually do it in the labs over here. This is the beauty of engineering. Or look at this. This is what we call as a computer numerical control machine, CNC machines is what we call. And look at the other side, on the right-hand side, on how it's trying to build. Or look at this other one here. These are nothing but the 3D printing machines which you have. And we are living in the future right now. And as you can see a 3D picture of Elvis Presley. And in fact, if you want, you can do your favorite Sachin Tendulkar or any cricket fan, whomsoever you like. And that 18-hour machine, which you can see, is the one which actually translates down into the lower frame, which decides on how it goes about. Or look at this, another example of a small 3D machine which is actually printing. And look at this picture on the right, where it's actually enabling you to do a 3D printing of a waterproof shoe with the midsoles and all that, which is actually being claimed, and all that is being practiced using the current day technologies of engineering. Or look at this aspect of what we talked about, synthesizing connections across areas. There's a purple colored chair of 3 different types here, and then you have the various components, which looks like an IKEA showroom piece, and then you have the small components of an aeroplane wooden piece assembled. Now, if you want to synthesize all these connections across, this is exactly what engineering does. So synthesis is nothing but combining information from multiple sources to form conclusions and then act upon it. And synthesizing is just nothing but putting it together as your thinking changes. So all this is actually leading you to synthesizing connections. Look at this. This is a small gearbox of your watch, which you have. On the side, you have this metal watch. Each one of the gears is connected to each other. As you can see, this animation very clearly going across. Or look at this. This is the picture of a small aircraft engine. And on the right-hand side, you see what we call the application of a Fibonacci series, where you can see the entire engine of the aircraft, which is actually being taken at a very close view as the wind, as it starts rotating. These are certain things which probably excites you. And this is something where if your curiosity stokes in here, you need to be here in engineering. Or look at this. In fact, Professor Murthy talked about biology engineering. This is nothing but a fact where we are having prosthetic limbs, where you can see one of them using a prosthetic limb. And all this is actually related to engineering, because the way the person turns around, a lot of biomechanics and all this goes around. But for that, the basics is nothing but engineering. Or ultimately, what does engineering lead you to? It leads you to intellectual development. And this is exactly what happens here. Now, at the same time, be careful about curiosity. Otherwise, this is what is going to happen. So therefore, what I'm going to talk about now is something very interesting for you in day-to-day life, but be careful on curiosity too. You have to have the safety aspect as well. So look at this cricket example here, which you can see on the screen. You see a lot of equipment which are required for protective gear, the helmet, the clothing, the thigh pads, the bat, ball, and many of these things. I'm not talking about the bat or the ball, which are normal. But then I talked about earlier the caution when you're curious. So the curiosity is primarily to find out in this particular case, how is this material of the helmet and the other safety equipment around this cricket, which is all going to be done. This is what you will see right now here. Look at this animation over here as to how the helmet is actually going to hit the batsman over here. Or look at this, how he's going to hit the bowler and he's just trying to avoid that. All this is possible with the helmet safety, as we can see here. Look at this. The helmet is actually being designed and it actually develops. What is this? This is nothing but engineering. And in fact, it's interestingly coincidental with today's mechanical engineering, where a lot of these things are actually part of the way you can design. So if you want to be part of a support staff or sports mechanical engineering, then this is exactly what you need to be in engineering. Then what exactly is engineering? The other advantage of engineering is, as you can see, the various kinds of fruits over here. There are various varieties of discipline in engineering. And this picture is just to illustrate an analogy between the various colorful fruits and different kinds of fruits which you have. And no matter what you choose, you can pick any of these fields which you want. So here is the typical list of branches which helps you to decide which one you could choose. It's just a sample set which has been listed in the alphabetical order. And you can say aerospace, chemical, civil, and so on and so forth until mechanical. And today, incidentally, you'll be hearing a lot from Professor Rajgopal and my esteemed industry colleagues. So actually been working on the field in the area of mechanical engineering. Thank you very much. And thank you, Shinde, and thank you, organizers, for having me on the panel. Thank you very much, sir.
Thank you so much, sir. Always a pleasure to listen to you. A good amount of information in terms of to students, why engineering, as well as why mechanical engineering. So thank you so much. Sir, could you stop the screen sharing? Thank you, sir. So we would now like to invite the next speaker for the day, Dr. M.S. Rajgopal, sir. He would be talking about, in specific, the mechanical engineering program, the specializations, and the program flow. Over to you, sir.
Yes, sir. Thank you very much, Mr. Shinde, sir. And I hope am I audible? And
yes, sir.
My screen? Yeah.
Your screen sharing you'll have to give, sir.
Screen sharing I gave.
Can you give it again, sir?
Is it coming?
Yes, sir. You can enlarge it as a under the slideshow.
No,
yes, sir.
Yeah.
Yes.
Okay. Once again, good evening and a warm welcome to all the students, aspiring students. So, and also there could be some few parents also. So welcome to you also. So you have heard from our Honorable Vice Chancellor, sir, taking what the future holds for all the students. So we had a terrible last 1 year. You have overcome all those things and trying to shape a new career. And we have had several of these sessions earlier. Okay. So today I will talk to you about the mechanical engineering. And incidentally, Arvind Srinivas gave a fantastic opening batsman. I think he gave a beautiful picture of what is mechanical engineering actually. But whatever he had shown, everything has become multidisciplinary. For example, the simulation of ball spinning, or it was hitting the helmet, or maybe a crash of a car, crash of an aircraft, crash of a ship, okay? Or he started off with a very simple example of a fan. What is a bevel gear mechanism does? And 4 different bevel gear mechanisms. And also he was talking about how the watch functions, okay? And all these things have become multidisciplinary. Basically, anything which rotates, anything which moves is mechanical. Okay, but it has been redefined. Of late, it has been redefined simply because man wants to control them much better. So a lot of electronics that has come into it, okay, and also a lot of programming so that at your fingertips you'll be able to control better, optimize the resources. On what we say about sustainability engineering, we use the present day materials which are sustainable so that man can live much longer on this earth, because every material, whatever you use, should be recyclable, reusable. So all these things are possible in mechanical engineering. Okay, I will just take you to a simple tour of mechanical engineering, what it holds you at Dayanand Sagar University. Okay, so actually the mechanical engineering program and DSU started in 2015-16. Okay, so 2 batches have passed out, and this will be the 3rd batch which is going to pass out this year. Okay, we have an intake of 120. We also have a post-graduation program, design engineering, okay, which also started in 2015-16. We have a bachelor of vocation program in tool engineering in collaboration with NTTF. We have started recently a BVOC program with a pharmaceutical manufacturing company, Strides Pharma. And of course, we do have PhD. 2 people have already passed out and other 17 are pursuing PhD. Okay, so when they pursue PhD, it could be in mechanical, interdisciplinary, and so on. So what is the faculty strength which holds? In simple terms, almost about 60% of the faculty, not just about the mechanical department, everywhere, in all the departments, nearly 60% of the faculty are PhDs from premier institutes like IITs, NITs, and even abroad. Okay, and the faculty have a good mix of academic, industry, and research experience. Just now we heard most of us have about 15 to 20 years experience in industry, and we have moved to academics to contribute to the society. So what is most important is the mindset of the faculty are always ready for change. As we are seeing, mechanical engineering has been completely redefined. We say reinvented. Okay, so this is a simple infrastructure what we have. I should say I worked in many colleges. We have the best infrastructure perhaps in Bangalore. Okay, so we have the typical labs, engineering, graphics, and design lab. We have lots of computers. We have more than 300 plus CAD licenses. We have a well-oiled and well-working workshop lab where we have the typical welding, gasketing, and the typical arc welding things. Okay, and also we have the carpentry, we have the sheet metal. Okay, we have the fitting, machining lab. So we take you all the students through what is the basics of mechanical engineering. What are the tools involved? How do we do simple machining and other operations? Okay, so we have design thinking and innovation lab. This is something we introduced last year, 2 years back, and since last year, it has become a credited course. Students are loving it. We are trying to make it better and better. This course it's a design thinking and innovation is not a cup of tea only for the elite people. Every engineer can innovate in a methodical way, in a scientific way, by doing a design thinking. So we take you through the basics of that. Then we have the materials lab, measurements lab, the machine drawing lab, the fluid mechanics, the foundry and forging, heat transfer, the simulation and modeling lab. You have the state-of-the-art software there, then the design and the control engineering lab. As I was telling, this control engineering lab holds the key. This is where all the electronics is going to come and you're going to write a code to control the machines. The curriculum design is very important. As we have seen, Arvind Srinivas took you through some fantastic examples. How are we going to make everything simulation is possible? The aircraft were used to take about 6 years to build. Now we can build it in about 2 to 3 years. An automobile design cycle used to take typically 3 to 4 years. It has been cut down to 6 months to 1 year. Okay, so how is this possible? It's a lot of contribution from the computer science. The mechanical engineers have given the domain knowledge, they have written the codes, and everything has become a software now. Okay, so in this curriculum design, what we do is we reinvent and continuously change to adapt to the new age demands. This is a typical function what we have. So we have a departmental academic committee where all the professors meet, they attend various workshops, they do a lot of projects in industries, okay, consultancy projects, they come with lots of ideas. These are the things we can change. Then these thoughts are crystallized, we present it to board of studies. The Board of Studies meet twice a year. So we have elite panelists in the Board of Studies, elite members, both from academia as well as from industry, and even from industry, from different sectors of industry, they will be there, and they will be constantly contributing, giving inputs to change the curriculum based on the needs of the industry. We have the Board of Examiners who will maintain the quality of the evaluation scheme. So they scrutinize the question papers and the practices what we have. The Academic Council finally approves it, and finally the Board of Governors. So we change the syllabus accordingly. This is the typical flow. And some curriculum highlights, I'm not going to go through the complete detail. The National Education Plan 2020 has been rolled out. A lot of things have come out. It's a big document. We will not be able to discuss on that. What impact it has made to engineering is some of these things. We were not having liberal studies. Now we are introducing liberal studies. We have humanities subjects, social sciences subjects, management, liberal art, music, yoga, and so on. So what is thought is the engineering should be blended with arts. The engineering, science and arts, we used to say now engineering and arts should come together. Arvind Srinivas was also telling multidisciplinary. Philosophy is coming into picture. How people think. And that should be adopted. The user experience, as you know, UX and UI. How do you use it? All these things are possible only when we blend these liberal science subjects with engineering, that is mechanical engineering. So these are some of the typical things. Basic sciences, yes, we need chemistry, we need biology, absolutely important. So we have modified the biology as health sciences course because of the corona, we understood that the medical science is extremely important, especially medical engineering. We have seen the shortages. We have to gear up for completely, increase in output at a very short time, how we have to do. So engineering is looking into more and more on the medical sciences. That's very important. So engineering sciences we had earlier, we are continuing. So in the mechanical engineering, you have two broad classifications: professional core courses, the basic courses, and we have the elective courses. Okay. So, and what is open courses? A mechanical engineer student can take typically about 3 to 4 courses in electronics or computer science or both. Okay. So he will take about 12 credits from the open courses. And projects, typically we have project stage 1 and stage 2 in the 7th and 8th semesters. And the mandatory courses are also there, like Kannada language, okay, then ethics and integrity. These are basic mandatory courses. So when I say projects, I will take you through other slides. Projects is not just in the final year, it will start right from first year itself. Okay. So the students learn the basics of mechanical engineering and the implications of that, and they will be able to express in the form of projects. Some of the best practices DSU has reinvented over the years, and these are some of the best practices in the last 6 to 7 years. We were earlier doing objective-oriented education, now we have become completely outcome-based education. This has been thoroughly changed into the curriculum. So every course will have a course outcome. What does this course, for example, if you are studying mechanics of materials, okay, how the forces are analyzed in the mechanics course, how do you find the strains and stresses? Okay, these are the outcomes. Okay, so the outcome is something what the student exhibits, what the student learns. So in every course, it is mandatory that the student should exhibit those learnings. Typically, we have about 40 to 50 courses. Together, these 50 courses will make the program. A program is nothing but our mechanical engineering program. So project-based learning, I will take you through that. We have also introduced another 2-credit projects called special courses from special topics from 3rd to 6th. This is where a student can express himself by taking multidisciplinary projects with other students from departments, individual or as a group project. Active learning is another important thing. We are trying to introduce now flipped classroom and blended classroom. What happened is earlier we used to be only in offline class mode. Okay, and last 1 year had been predominantly online course. So going forward, almost everyone is sure that it is going to be a blended learning. It in fact helps to learn better. The students will be exposed to online, offline, so you can move between the two. Typically about 30 to 40% we are expecting the delivery can happen over online. The remaining things and labs and other things will happen in the campus. The flipped classroom is Typically, what we used to do is a teacher delivers, student goes back, learn, come back and ask doubts. This is a typical classroom scenario. Flipped classroom is I encourage the students to learn on their home, either as an individual or a group. They go back, learn, come back and ask doubts, make presentations. This will tremendously improve the communication skills and also interpersonal skills, okay, and improves the critical and creative thinking as well, okay. So our labs are completely hands-on. We have all the courses are integrated, all the theory courses are integrated with labs, and every lab has an open-ended experiment. We have the usual experiments, but the final experiment will be an open-ended experiment. The student can express, he can come out with his own experiment, okay, and some very good experiments set up whatever the students have done or the projects will become a standard experiment in the following year. Okay. Summer internships are thoroughly encouraged. It will be both on and off campus. We have a Moodle-based learning system where the entire course material and whatever the learning material is there, we are going to upload it to Moodle-based. It is available for students. They can go back and refer. And most importantly, we have introduced the minors, specialization and honors. So this is something what we did from last year onwards. So I will take you through that in the coming slides. Okay. So BTech program is a basic minimum, a major in mechanical engineering. Okay. A student should get 160 credits. We have a flexibility of about 5%. That means 160 into 5% is about 8 credits. So it will vary between 162 to 168 credits. Okay. So as we have showcased today, a new age engineering. What is new age engineering? Earlier, it was different. It was generic mechanical engineering. So what we are proposing is a mechanical student who was enrolled into mechanical can get a specialization in robotics and automation by taking about 18 additional credits. If you look at the first 2-3 batches of students passed out from DSU, they were doing 192 credits. Now the credits has been brought down to 160 credits. Keep learning same. That means the students is encouraged to learn more. Per credit, you are learning more. Okay. So what we are trying to do, either you can get a minor or you can do a specialization with an additional 18 credits. So a mechanical student can get either in robotics and automation or advanced manufacturing. It's also called as digital manufacturing or additive manufacturing. We also have the green energy systems. This is nothing but sustainable engineering. Entire engineering is getting redefined because of the green energy norms. Okay, and emerging automotive technologies, this hybrid and electric vehicles. Okay, this is going to be the key, and you also know that it may become autonomous vehicles. Okay, just rush through this slide. So these are some of the, I was telling about 18 credits: robotic engineering, advanced manufacturing, green systems, emerging automotive. So a student can get to do any one specialization in either one of this. What is a minor? So a major in mechanical engineering, he can take a minor in aerospace or an electronics or CS, okay, or he can do even a minor in entrepreneurship. Okay, so what is it required? Mechanical engineering completely getting redefined. So it is becoming multidisciplinary, where electronics has become a must. A typical automobile, which used to be 95% mechanical, now about 60%, it is only 60% mechanical. Okay, even the IC engine based. Once the electric vehicles come, I think it will go down to even 40 to 50%. Okay, so we are trying to inculcate that philosophy, okay, that mindset, and bringing into the curriculum. Okay, so BTech honors. This is another idea where good students, they're in fact advised to take MOOC courses, massive online courses. Okay, so they're free to express themselves. They can take few courses in NPTEL, Coursera, Udemy, edX. edX is nothing but Harvard and MIT. So completely given flexibility to students. Okay, so I'll not take much time on that. So what does it hold for a typical student who is joining this year? 60% continuous internal assessment. So earlier it was only 30% continuous internal assessment. First year when we started this. Now that we have matured enough, we are extremely confident a student will learn more during the internal assessment. We have a very good evaluation scheme. If a student doesn't perform well, we give him one more chance. If he doesn't do well, we give him one more chance. A student is encouraged to learn, express, come out with better problem solving skills. So these are some of the things how we assess them. Sit test, assignments with Viva, quizzes, mini project. Okay, he can attend webinars, seminars, go and attend some hackathons and give that as for credit. Okay, in all the subjects, this is increased. Okay, the semester end exam holds only 40%. So a student, when he takes final exam, he is already assessed for 60% of the marks. Okay, so project-based learning. So we have actually DSU is called as the innovation campus. We have about 9 innovation labs. We are improving that to 13 labs, and subsequently it will become more and more. Now, presently, mechanical has 2 major innovation labs. The Autodesk Innovation Lab is a product design innovation lab. This is embedded into the curriculum. So the Fusion 360 software, which is nothing but a cloud software. A student, when he enters the first semester, he can download the software on his laptop and he can create his portfolio using this software. A mechanical engineer typically will be doing about 8 to 10 product design of various complexities projects. So your entire projects will be in your laptop. Every day you bring, you express, you go back home, you work again, come back, and it's like you are carrying work home and back and forth to the campus. These are some of the projects done using our innovation lab. We also have a space there, which has a reverse engineering lab, having a 3D scanner. We also have 3D printing machines there. Whatever models you do, you can take a 3D printout of that. I don't know whether you are able to see the full screen. This is the Bosch Rexroth Automation Technologies lab. So this is another very critical lab for mechanical engineers. As we know, automation is the key. The jobs have come down. The skills, it is becoming completely automated. A productivity enhancement has happened. Okay, slowly the laborers are being replaced by machines. Okay, earlier India adopted a semi-skilled, semi-automatic approach. Now slowly it is becoming completely automatic. So a mechanical engineer should learn the automation basics. So we have the hydraulics lab, pneumatics lab, the program logic control, drives and controls. Okay. So, so you also know that we have 2 major major clubs for students. This is the automotive club. As you know, students, we have the Racing Society of Automotive Engineers as a Baja and the Supra, the typical 2 racing cars and the all-terrain vehicles. Okay, they have also added the agricultural-based project. So we have been competing in this. Twice we won the prizes. Okay, and we have made a lot of inroads, and almost about 20% of the department students will be involved in SAE projects. These are some success stories. Okay, internships. Okay, you can see Bosch, ERC, Hyderabad, Mahindra Aerospace, SAIL, IIT Madras, ISRO, BEML, HAL, Robert Bosch, LC. So Mr. Guru Venkatesh will talk more about this. This is typical list I gave. Okay. So without taking too much time on that, what are the typical jobs we have? Vice Chancellor sir was telling the traditional jobs are getting replaced by new age. Okay, that's what we are debating today. So design engineer, CAD engineer, CAE specialist, shop floor engineer. These are the old ones. Shop floor engineer, production supervisor, planning engineer. Everything is getting automated. Earlier, there used to be at least about 10 production engineers in a shop. Now there will be only 1. Okay. So methods engineer, continuously make improvements, quality assurance, maintenance, safety, R&D, marketing, and so on. Okay. So the other opportunity, career opportunity is higher education. Many of our students do post-graduation in India as well as abroad. So what are the typical domain where they can go? They can do in mechanical domain, design, advanced materials, additive, 3D printing, product design, robotics. Then don't forget the major one, automobile and aerospace. So automobile, vehicle dynamics, vehicle engineering, controls, then computational fluid dynamics, energy engineering, this on the thermal side, renewable engineering, aerospace, aeronautics. Okay. And now it is open for interdiscipline. A mechanical engineer can do a master's in biomedical or an environmental engineering or in mechatronics, also in data analytics, AI and ML and IoT. So these are the other avenues which are now opening up. Okay. And what are the skills we are trying to inculcate in a mechanical engineering student. We have virtually all the software, CAD software, CAD, CAM, CAE software. Okay. So product design is a must. As I told you about, typically all students will do about 6 to 8 product designs. Automation technologies lab, I told you about the innovation labs. In addition to that, we have introduced the programming skills. You are going to do 2 programs in the first year itself. In addition to that, we have the special topics where you are going to use AI and ML for all mechanical projects, okay? Data analytics and IoT. In the open electives also, you'll be able to learn these subjects, okay? So I think I will close at this, maybe I took a little bit more time. So as a closing remark on this, mechanical engineering has been completely redefined. You should be an all-rounder. You should be strong in your basics of mechanical engineering, plus you should know good amount of electronics, and you will be trained very well in the programming. Okay, with electronics and programming skills and your sound mechanical engineering knowledge, you are most sought after in the industry. Thank you very much.
Thank you so much, sir.
Thank you, sir.
It was an in-depth knowledge to all the students in terms of how the revaluation of the mechanical engineering program is done at DSU. It will definitely, with the interdisciplinary approach, will always put you in demand when you move for the job per se. So thank you so much, sir.
Thank you, sir.
We now move on to the next speaker, speaker number 4 for the day, Dr. K. Ramchandra. And Dr. K. Chandra will talk about the industry perspective more towards the modern day mechanical engineering. Over to you, sir.
Srinivas, I'll take a moment. I need to share the
Sure,
screen.
sir. We will ask sir to Dr. Rajgopal to stop the screen sharing.
Yes, yes,
Okay,
yes.
okay.
It will be on the top, sir. Take it extremely on the
yes,
top.
yes. Stop sharing, right?
Yes, sir.
Click on the Zoom icon.
Oh, yes, 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 I got it. Thank you.
Yes, sir.
There's a button, stop share. Yeah.
Shall I get started?
Yes,
Srinivas?
sir. You can please
Now,
go ahead and do
need
screen
to-
sharing.
I forgot to bring it on the toolbar, so I'll take a moment more. Yeah, I'll start sharing.
Sure.
Well, it's not my screen, Srinivas.
Is this your screen, sir?
No, it is.
Do you want me to present it?
If it is okay, no, because then I need to bring it from the desktop.
No, what I can do is I will present it and
okay, all right, then it'll be faster, I think.
no problem. I'll just present it right away.
Right.
Just give me a second and I'll put it up on the screen.
It's on the
No problem, sir. Just give me a second and I'll put it up on the screen. Sir, are you able to see it, sir?
all right, great. Okay, so that is there. 1 second, 1 moment.
Are you able to see it on the screen?
Okay, I'm fine. Great, thank you. Thanks for the help. But then we'll go to the next Srinivas, if it's okay.
Yes, sir.
Yeah. Yeah, great. Thank you. Now, at this point in time, very good evening to all of you. Welcome to this interactive session to all the students and the parents who are there, and wish the students every big, bright career and opportunities in mechanical engineering. I must thank at this point in time to the Vice Chancellor of the DSU and the Chairman and other people who have enabled this event to happen today now. Now, the focus of this today's event is we'll see the role and career opportunities of so-called modern day contemporary mechanical engineers the mechanical engineers in industry and R&D labs, how they're very adaptable and how they're the right fit in several segments of industry. And we will also look at the training facilities for mechanical engineers to meet present industry expectation with the new age specialization, with all the speakers before me spoke about. Srinivas?
Yes, sir.
And then it's a little loaded slide, but I just wanted to make sure mention that not that one, previous one.
Yes.
Yeah. So it's a traditional mechanical engineering. It still remains a core, one of the core engineering disciplines, notwithstanding the passage of time. And so much of advancement has taken place in the last few decades. And therefore, the efficiency has improved. Efficiency of development, efficiency of training students have increased. And therefore, time and cost of engineering development is the core. The engineering curriculum is therefore continuously being redesigned to address this dynamic environment which the Vice Chancellor was talking about. There is a continuous and effective reorientation and retraining of mechanical engineers. And this has been endorsed fairly well by the new education policy, Niti Aayog, AICTE, UGC, and the university BSUs, for example, is very sensitive to this need. Now, present dip, which you might be having as a suspicious thing, is a very temporary aberration, and you don't have to really worry about that. It's bound to spring back. In fact, if you look at the various studies that have been done, the projected growth of the employment of mechanical engineers in the country, and even in a globally, the Bureau of Labor Statistics say is going to be about 10% by about 2026. So I think we need to shed this fear or apprehension and give a dash to look at mechanical engineers as a core engineering discipline which you can opt for. So the students who complete mechanical engineering now have a plethora of opportunities in many disciplines. The various speakers have said this: aerospace, automobile, chemical, manufacturing, railways, energy, oil exploration, and so on. And you're also fit for a major R&D environment, R&D activities, and among so many others. Srinivas, next one. Srinivas? Yeah. Now, I just wanted to make sure that you understand what I'm saying. This is a pictorial view of what I said. The contemporary, today's mechanical engineering is a good fit in almost all core industries. And they are going to be the nodal points, a technology driver, technology drivers, and integrate well with most of the disciplines. For example, aeronautics, you may be building aircraft, helicopters, or drones. You may be talking about automotive industry, cars and trucks. And on the left side, you see you have the aerospace. It may be launch vehicle or satellite. There are also marine engineering disciplines, building of ships, seaplanes and operation of seaplanes, for example. We are talking about green energy today and energy and environment. You fit in, the mechanical engineers fit in, and not to forget the core activity, the steel, materials, metals, and manufacturing activities. Mechanical engineers blend with this, and in fact, they're in great demand in each of these major disciplines of economic and engineering activities in the country. Srinivas. I just wanted to highlight here, if you look at the typical staffing and training pattern and effort that's required for any industry, and in particular with reference to mechanical engineering in industry and R&D labs, you take, for example, advanced technology product development agency or an R&D establishment, the training focus for the mechanical engineers who come out of the engineering institutions is having this focus. There is multitasking, multidisciplinary and interdisciplinary, and teamwork. The graduates who come out of that, they need to be trained and they have to be placed into the industry at various disciplines. You look at the top bar that I have projected. If you look at a team, an organization with a team strength of about 400 to 500 engineers, typically this is the distribution of different disciplines. If you look at the mechanical engineers, they constitute about 30 to 60% of the entire engineering team strength in any typical industry of that size. And of course, there are electronics, there is computer science, telecom personnel, material engineers, electrical, and of course, administrative MBA guys. So this is the sort of scenario where you can see that a typical organization of this size might have 30 to 60%, and in some cases it could even be 70%. And I'm not talking about IT industry, IT industries, but typical product development industry or major industries. And this is the intake part. But these mechanical engineers, maybe 60% or with 30%, they need to be trained. They will be trained for about a year or two and then placed. Amazingly, you can see if you take a survey of their position in the organization, they fit in almost everywhere within the organization, and the job description in the organization. You see that they fit in for project management, the sales and marketing, purchase and admin, more importantly, design, materials, manufacture, and testing, and including aftermarket and field support. So mechanical engineers are in great demand, are basic necessity to man various disciplines, job descriptions within the organization. The point I'm making here is 70%, 60% of mechanical engineers, they are brought in, trained, and put into various activities. Most of it is for design, manufacture, assembly, and testing, but they fit into all other major requirements of activities in the establishment, in the organization. The point I'm making here, the industry spends, R&D lab spends about a year or two to train them. It can be a basic reorientation, formal training, or on-the-job training. This is 1 or 2 years spent on these budding engineers out of the institutions into the jobs, into their portfolios. And this is what the industry wants to avoid, minimize if that can be done. And the present syllabus, present training schemes that the university has tries to minimize this 1 and 2 years of training, on-the-job training, which the industry or the R&D lab takes, and make them almost ready to go into the job situation as much as possible. And this is the advantage of the present-day syllabus, present-day training schemes, which the universities and the institutions are hoping to achieve. And I'm sure you will be the beneficiary of this change of attitude. Srinivas. Yeah, so this is something which I wanted to tell, the need, the type of expectation, the redefining the expectations and the role of mechanical engineers in the present context, the changing context is shown here. The expected skill profile of mechanical engineering, if you see, it is a changing scenario. It's a very dynamic scenario. And the university is making its best effort to bridge this best gap. And what is the gap I'm talking about? Present scenario is in the top half of it is present or previous. What we are expecting is shown below as a comparison. The theoretical and practical knowledge in basic work is a limited one. I mean, I'm not saying everybody is not good, but it is limited by the time that we have. Unfortunately, this is the state of affair. The knowledge in allied fields, a mechanical engineer doesn't have much exposure to related fields, maybe electronics, maybe computer science. He has got very little time and training, and therefore knowledge base in these allied fields is very minimal. And if you see the next one, hands-on experience is also being not very good. We don't have enough time and effort put in to get a good hands-on experience. And there is some good project work going on. The communication skills are not bad, but not as good as it should be. What is expected is shown below. Today's engineer, mechanical engineer, is expected to have a much broader theoretical and practical knowledge in basic mechanical engineering subjects. And therefore, it should be much broader. But more importantly, they must have much better knowledge in allied fields. They must know what is programming skill, what is instrumentation, telecommunication, and so on. So we are expected to get you exposed to these additional allied fields. And most importantly, everybody has stressed this point, that there is a need for the mechanical engineer, present mechanical engineer, to have a good proficiency in a few new age disciplines. What are the new age disciplines? It is listed on top. the artificial intelligence, machine learning, data sciences, programming and coding skills, additive manufacturing or additive advanced manufacturing techniques, e-mobility, and of course I forgot to mention about the energy systems. Now then it's also required that we need to have more hands-on experience. Present hands-on experience is not adequate, and therefore there is a need for augmenting that practical laboratory work, and that has to be augmented. And that's being done, that's being planned in a very big way. And then the important thing is the projects that we do need to be industry or society-oriented project works, and we're trying to get interconnected with industries and look for societal programs, projects which are societal, which meet the societal needs. And I'm afraid this is something which is a basic thing we have seen, that we need to improve our communication skills, both written and oral communication skills. So there is the one previous, and there is a one which is being looked at in the coming years. So this is the one which defines what is being planned for training the incoming mechanical engineering students. And this is, of course, true of other disciplines, but it's much more important for mechanical engineers. Srinivas. Okay, now, therefore, if you look at what are the things that is likely to happen once we enter, say, the DSU, and in the Department of Mechanical Engineering, what are the different advanced technologies that mechanical engineering students will be exposed to during their internal industrial internship programs, University Innovation Center, which Dr. Rajgopal was talking about, tinkering labs, and several multidisciplinary and interdisciplinary industrial-driven projects, which will be mentored by the faculty and the external experts. You can see, for example, mechanical engineering technology for aerospace propulsion. You're not simply a mechanical engineer. You're with a mechanical engineering background, but with the type of input that you get, the training that you get, you will fit in very well for these applications. And you will be exposed to these technologies. Aerospace propulsion system, just to give an example of bearings, high-speed, levitation bearings, advanced high-temperature alloys, composite materials, and so on. It is also possible that you may be interested and you'll be supported for looking at drones, marine vehicles, hybrid vehicles, network systems, advanced data processing. And of course, you're aware of e-mobility vehicles, autonomous vehicles, range extenders, charging station network, battery technologies, and fuel cells. And not to forget the emerging technology of advanced manufacturing, or the additive manufacturing of gas turbine parts, very complex, very critical, and automotive components and subsystems. So this is what you will be exposed to today, which was not there before. And I want to look at these three small little video clips I have there. And these are typical examples of the capabilities of mechanical engineering students who have done this sort of projects in advanced technologies, which includes a bit of robotics, of automation, artificial intelligence, and so on. Srinivas, can you click on the top, first top video? You have to click on that. No, you have to click on the image, and then you see. This is something which is this is something which is a hexcopter for agricultural spraying purposes. It has got its intelligence put into that to spot where the spraying can be very, very critical, what height it should fly, and can it avoid pollution, and so on. The next one, Srinivas, the next middle, yes, that one. And you can see this is an autonomous boat which was developed by students. It is unmanned, it is programmed, and it is able to move the way it is programmed 24/7, continuously monitoring the water quality of the aquaponics. It's an autonomous aquaponic boat to ensure that the water quality is continuously maintained, and it wants the fisheries department and the owner of this funds. And the next one, Srinivas. Yeah, you can see what the students can do. It's something amazing. Today, we understand this is a seaplane, which is a combination, with reference to the subject matter. It combines aerodynamics and hydrodynamics. And the students are able to design, manufacture, fly them, and to understand the subject of seaplanes well. And this is likely to get into a bigger business. So with this background, today, the students, mechanical engineers, are trained to handle, now there's no video, don't worry about it. They're trained to handle such future challenges. And I'm sure you students there have seen this many more times. This is the drone, which is there in the NASA drone, which is trying to gather information on Mars. And this is a rover, the center one, and that is the drone, which is flying all through ground control, thousands and thousands of kilometers away. So this is what you're capable of doing. You'll be made capable of doing. And therefore, this is the challenge which the mechanical students will face and succeed. Next, Srinivas, this is the last one. Yeah, so therefore, the summary is the mechanical students will be enabled to hone their skills to meet the required, to get the core expertise in mechanical engineering domain, which to meet the dynamics of the present situation. Additional programs and specialization in artificial intelligence, machine learning, additive manufacturing, e-mobility, we all talked about. You can specialize in any one of them with a huge background of mechanical engineering. The university will provide the augmented lab facilities, innovation centers, tinkering labs to ensure better hands-on skills. And we have internship programs, which Dr. Rajkumar was mentioning, mentoring in multidisciplinary and interdisciplinary. This is a must. You don't have to have blinkers on and say, I am mechanical engineering, I don't know anything about that. You're no good. So you must have the multidisciplinary and you'll be trained to do this. You'll be supported to take up these activities inside. So to state the obvious, mechanical engineering and mechanical engineering, the reality with this time-tested reality is they're the basic building blocks for any industry. Mechanical engineering is a basic and bulk requirement for any industry to survive. Employability will improve due to the dynamic and need-based training in the university. The university is making a lot of effort to get all these things in position before you come into the system as students of mechanical engineering. We are expecting a lot of big spurt in employment growth, and therefore the right choice to opt for mechanical engineering. And the present scenario, which you are maybe apprehensive, is a temporary transition phase, and will certainly take an upward positive slope. And with this, we hope that you guys make up your mind and choose mechanical engineering as a possible option for engineering career. So this is all I wanted to say. Thank you. Thank you very much. One slide is there. There is a thank you slide.
Thank you so much, sir. It's a pleasure knowing the industry practices and sharing your thoughts on this. So thank you so much. We now move to the next speaker, another industry practitioner, Mr. Pankaj Bande. Over to you. And Mr. Pankaj Bande will be talking about conversational artificial intelligence and future of machines. Over to you, sir. And the screen sharing option is given to you.
Thank you, sir. Very good evening to the Honorable Vice Chancellor, Chairman, and all the other members, and especially the students and parents. I know it has been long time, and you have been hearing a lot of very valuable level of information from the best of the experts in their domain. I just wanted to start with things because it is about conversational AI. So, I'm holding something. I don't know whether you guys are able to see this.
Yeah, you can see it.
Yeah, so it is more of it's a remote, right? All of us know that this looks like a remote, and yes, it is a remote. Okay. So all of us know, yes, there's a mobile phone, which is there in my hand. And then I have one of the device, which some of you might be familiar with. Students, you can drop in if you know the answer to what is this device, maybe. And then, even the question goes to next level, that I am presenting something on the computer, I have a device in hand, which is more like a, the way it looks like. Then there is a remote, and then there is a mobile phone. So what may be that one common thing which all these four things, the PC on which you are hearing my presentation, this device, or maybe the mobile phone which is full of apps, or maybe a remote control may have in common. So that's where, I come to the world of, I bring you to the world of, is there an answer in the Q&A? I would be more than happy to, hear it out. If anyone of you can guess what is common amongst these four devices, what is that thing which sits common in all four devices? And, there is more than one common thing at all four. The PC is a product, the mobile phone is a product, the device which I am talking about, this still keeping it a bit unknown, is a product, and the remote control also is a product. But what is common amongst these four devices? So if I, let me see if there is an answer in this case. Microchips. Okay, so Nikhilesh is trying to say it is microchips. Tejas says that is mechanical engineering. Okay, so Tejas is having a question, but Nikhilesh is saying, microchips. Wow, that's a very good, answer, Nikhilesh, that yes, there is something which is common amongst all four. They have some sort of a, chips actually, right? So I would suggest, if you guys still know the answer, please drop it in the chat window while I still give you a moment, right? But because my topic is about, conversational AI, we must first start with that AI. Is that AI at present, this meeting is happening, and is that AI with us? Is this AI, which I say, is also hearing from such prominent speaker, right from the likes of the Honorable Vice Chairman, to Dr. Rajagopal, to Dr. KNV Murthy? Was this AI also hearing this very topic of, the future of mechanical engineering? And how is this AI getting smarter? What is the source of learning for this AI? So whatever you are able to hear as humans, as parents on this call, as students on this call, the AI is also present. And it is present in this remote. It is present in this Echo Dot device, always listening. And it is also present in this PC. And it is also present in this mobile phone as an app. So this AI is also always listening, and it is listening every aspect of every expert's input, and it's learning basically. So that's what is a future which, we need to understand, that if the machines are going to understand everything which we do day in, day out, and at present it is hearing things which are done by the expert, but during the daytime, me, my wife, my daughter, we are there inside the home, and we are doing daily stuff. We are cooking food, we are eating together, we are enjoying. So she is understanding family that time, that AI actually. So this AI is everywhere. It is there in the cars, it is there integrated inside televisions, it's there in the washing machine. It's coming everywhere, and it is conversational AI, an AI which can hear, an AI which can talk. So if I have to say this and I can't prove this right away in this very next minute, it may not make sense, right? That am I really exaggerating, or what is the case, right? So let me, prove it. First thing. So all of us know the mobile, and in this mobile, if my screen is visible, I'm talking about one of the examples of AI is Alexa. So, okay, so she is a app here, and I just do one thing.
Sorry, I don't know that one.
So she heard her name and she started talking. Knock, knock.
Knock, knock. Who's there? Oyster. Oyster who? Oyster the pot. The chowder is burning.
So she spoke on this. Let us take the second turn. Alexa, तुम कैसी हो?
आपसे बात करके मैं खुश ही होती हूँ.
Okay, so I spoke with her in Hindi, so she understands Hindi. This remote is connected to my TV, and it is a Fire TV stick, and all of us know that this is a product available in the market with inbuilt Alexa, right? And now let me share my screen.
Sorry, I don't know that.
And once I share my screen, I will also be able to show you that she is also present on my PC as such. Okay, so I just open it up here, and she's available as a web app here. So she's a mobile app in a mobile. She's inside a remote control. She's available as a specialized device over here, and she's a web app in a mobile phone, in a PC basically. So she was hearing this entire expert session from such prominent people, and she's trying to learn out of it, right? So if you tend to look at it, conversational AI is coming parallel to us as humans, basically. It is coming parallel to us as humans because the source of this conversational AI is humans, what we do in our day in, day out life, right? And still then the question goes back that how is mechanical engineering, connected to this? So, as Nikhilesh, one of the person actually, answered that chips are common amongst the PC and the Echo Dot device and the mobile and the remote, but these are physically designed products. A remote is still designed so beautifully by a mechanical guy with CAD design. There is a PCB inside it. So there is a PCB electronics engineer. There's some firmware with the microcontroller. So yes, some sort of embedded system engineering is there. Same is the case with the way a mobile phone is designed. And then if we even look at, the Echo Dot also as a device, which is here, this is also beautifully designed by a mechanical engineer. So if you look at these examples, the machines of future will be designed with conversational AI inbuilt inside it. The machines will be able to talk, and whatever you want to do, whichever branch you want to pick, I can directly talk to that remote and say, hey, what is the processor used inside you? And it should be able to answer, hey, what is the RAM of that processor? Hey, what is the language which was used to program you? And that remote itself will talk about itself, right? That I am being used with a STM32 microcontroller, and I'm being programmed using C++ or C as a language, and it can talk back to you. Why? Because conversational AI is going to change the way we actually look at the future. So then you will say, if it is future, what am I supposed to do in the present? And any of the company which will want you to be a prospective candidate in their company, contributing something which is definitely futuristic, it has a present today, and it has obviously a very, very certain future, is look at these, how these companies are coming together. I'm just trying to showcase, and this link is something which I will share in the chat window, because I want you guys to, after the session, look into it. Why are all these companies coming together? And even if it is under the Amazon's initiative, why Amazon and Accenture and Acer and M-Logic and AMD, and then most importantly, the Audi, the automotive giant, then BMW, the Bosch, and then, suddenly the music experts, the Bose and the Dolbys of the world. Why are they here? And then why Intel is also here? Wow, Intel is also here, and they're all coming together. Oh, Microsoft is also here. Wow, that's even great, right? And the likes of Sony is also here. I'm just trying to pick the ones which, we are quite familiar with, and they have nothing in common amongst themselves. If you look at it, many of them, NXP, next generation Philips, even this company which is into, pretty much into the semiconductors technologies, is still here. And then, if we keep looking at all these companies, you can even look at them in terms of, the alphabetical order also. You will be able to surprise that what all these companies are trying to do, and while they are trying to come together. And that's what is called as Voice Interoperability Initiative. So it is this initiative wherein every company in the world is now trying to design machines with voice as a major thing. Conversational artificial intelligence, which is predominantly nothing but voice. That how do you design a machine which has got voice inbuilt? And I do every task by talking to the machine. So I have to relook at everything which I have been doing in my past. Why? Because look at the members. They are already there. And these are 89 in numbers actually. These are just 89 companies in number, and this number is growing. The likes of Facebook is here, the likes of Xiaomi is here, the likes of Intel is here, the likes of Qualcomm is here. So if all these companies are already here together, what are they trying to do when they say that it is Voice Interoperability Initiative? The Audis will still keep making cars, and the BMWs and the Bosch will still remain, although it is in many areas, but one of the areas of automotive parts manufacturing and designing things. But the likes of a social media giant Facebook is also here. So what are they trying to do? They are saying that we are getting into a future wherein any product which we will design will have conversational AI inbuilt inside it and will coexist. So this simple remote which I was handling can do the job of a Facebook agent, can do the job of a Audi car, can do the job of a BMW, can do the job for a Bosch assistant or an IT company like Accenture, or it can be even a chip manufacturer as big as Intel actually, right? So this is what I'm trying to, present in this topic of my 5-10 minutes. And you might see that, if this is too futuristic and is it really going to be, something which is possible for me? Believe me, guys, that I am trying to show you these things, but kids are actually already programming these devices now, the devices of the future. And the surprising thing is, all of you think that computer science is the most dominating language. The fundamental question is, what is the programming language for conversational AI? Which language will be used? Again, I give a moment if someone wants to answer. If you want to know that, what is the future of programming? What do you think that computer science and AI will dominate? What is the programming language with which a machine will be able to talk? I want to do a job using a mobile phone as an app. I want to buy an item. I open the big basket. I choose the item. I put it in the grocery. I actually, then check out in the cart, and then essentially I place the order by paying. In the world of conversational AI, I might just say, please add this and place the order, and the order comes to you. Such is the power of conversational AI. But what is the programming language? And surprisingly, there is no programming language. Human language is the programming language of the most advanced machines in the world. So why do you think that computer science is the major branch? There is no programming language in conversational AI. Humans just learn by listening. These machines are also learning by listening. The more they listen, the more they learn. The more they listen from such prominent speakers, the more they learn. And the more they learn, the more they come and compete with you. So where do you still remain ahead of it? You have to first understand how these machines are getting smarter and how these companies are coming together and creating a future which is today. And why this is most relevant to the audience on this call is because this will be in practice in 4 years. This has started. This is at still nascent stages. And along with these companies, I am a contributor to this. My daughter is a contributor to this. I program this Alexa device. I program things, and it is open for me to teach whatever I want her to learn for myself, right? So that is what is a key here, that the future belongs to people who know what is the present, how I start contributing to this present, so that, I essentially end up seeing my future as at an incremental level. And whatever was shown in these presentations in terms of the syllabus of mechanical engineering holds 100% true. You must know the fundamental subjects of mechanical engineering, the interdisciplinary aspects of it, and add a top layer of conversational AI. How will I make this subject of mechanical engineering to talk back to me? Forget about just a machine. Talk about a subject. Why can't I make a subject to talk back to me? We know that these things happen, right? You give an AI to read a book, it will read, and then you talk to that, right? So then, there is a surprising element. What may be the price? What is the money? See, we got such prominent people on this call. They have spoken almost 15 to 20 minutes. The world of Amazon conducts a competition, and they say that if you are able to program this device and it is able to do a conversation for 20 minutes, what is the money Amazon will give? What is the money, which Amazon will give? And you will be surprised to see, if you try to guess a number in your mind, just program the Alexa device in such a way that it is able to hold the conversation with a human for 20 minutes. We are able to do this conversation with you people so easily, 15, 20 minutes, half an hour with the kind of knowledge. But where is the money going? So look at the price. The price is $1 million. If you are able to create a conversation with a conversational AI for 20 minutes, you get $1 million. Why would someone give? I can speak for hours, man. Please give this money to me. A part of it also will be helpful for me as a human, for all of us on this call. why the hell someone is giving $1 million to program a conversational AI device just so that it can do a talk for 20 minutes? Because that's where the key thing is, that machines, as I said, it is in the remote, it is in the app, it is in the PC, it is in the special device like Echo Dot, it is in washing machines, it is in the cars, it is everywhere. And it is learning, it is always getting smarter. And the most importantly, suppose my mother tongue is Marathi, it is learning in Marathi. If there are people on this call who have native language as Kannada, she is learning in Kannada. If you are a Malayalam person, she is learning in Malayalam. So these machines are coming parallel. And if you want to interact with this machine in any language for that matter, you will see that yes, she is able to talk. And I'm pronouncing it as she, because in most of the cases, the voices are given to the ladies part of it. But yes, there are other versions of it. So it's being predicted by 2028, it will be impossible to differentiate between humans and machines. You are talking on the other side to a human or a machine. And it won't be a surprise that in one of the webinars after 2 years in Dayanand Sagar University, some of the conversational AI representations done by companies will be a part of this webinar, and they will present their specialization. That I am a conversational AI agent from Intel, and let me talk about Intel, right? Believe me, that is where this world is going towards. And now you might say that what this has to do with mechanical. Again, if I bring you back, as I said, every of these things which I'm talking about will be still designed by the mechanical engineer, the electronics engineer, the designing part, the programming part, the PCB designing, the CAD designing, everything will be still done. And it will coexist with the way we speak with that end product, like a washing machine or a TV for that matter, right? So these are the things which, are the key to the future, that please know presently what you can do. And that's where now the last opportunity which I want to, present to you guys is that after this call, if you want to see how all of this is happening, just look at one of the webinars, given by the very, senior architect from Amazon himself, how these companies are coming together and creating, the principles of how machines come together and coexist with us as humans. And that's where it is all about going to be. It will change the way you look at every single thing in the world. It is all about, talking and getting the thing done. And surprisingly, the programming language is human language. There's no programming language for conversational AI. And I don't want to use any programming language for that matter. And I'm not saying the programming languages are getting away. No. The part of the processor will still be programmed using C++. The cloud elements will still have the JavaScripts of the world, HTML, CSS, React.js, Node.js, AngularJS, and all of that. But the most powerful programming language is a human language, and that is natural to us. But the machines are learning it. Okay, so that is what I had, in this 10 minutes of my time, team. And I know, this has been a great learning session for me, especially, hearing out right from the Honorable Vice Chancellor, to Mr. The very, the best presentation done by Mr. Tejas Prasanna, means the person from TCS, right? The way he was able to get so many areas, I always feel that, we are still safe as long as, we have people with such a beautiful way of bringing so many fields together, and, and then the overall knowledge being actually followed by the other speakers. Okay, so we are only as safe as we actually, do as humans, because believe me, machines are coming and they are going to stand parallel to us, and God only knows what will remain with us if we don't actually, go beyond what we are doing today. Okay, so thank you so much, Shinde sir and Honorable Vice Chancellor sir, and to the entire Dayanand Sagar University team for, giving me this opportunity to present myself. Thank you so much.
Thank you so much, Pankaj. Lovely presentation, lovely inputs, and good amount of questions coming in from most of the students. So I'm sure they enjoyed this, and thank you once again so much. I would now like to invite the next speaker of the day, Dr. Sharad Kumar Varier, and he will be talking about on the topic of additive manufacturing. Over to you, sir.
Thank you, Mr. Srinivas. Very good evening to all of you. Good evening to respected Vice Chancellor, Chairman, members of the faculty and officials from Dayanand Sagar University, and the children, the students and the parents and the guardians who have all come here together to learn what are the prospects for mechanical engineering. As a person from the industry, it's my privilege to share with you the current progression in one of the emerging areas called additive manufacturing. And I choose today to talk to you from the perspective of a mechanical engineer, because you can look at this emerging area from many, many angles. I'll be drawing upon some of my experience with one of the industries which is using this extensively, which is the aerospace industries. Specifically, I've been working with Collins Aerospace, and also I had a chance to interact with a lot of industries to get some of the information I hope to share with you today. Let's start with what is additive manufacturing. Additive manufacturing is sometimes also referred to as 3D printing. It's a process of joining materials to make objects from 3D models. I've got a picture on the right of the Eiffel Tower. So you got a picture of the CAD model of the Eiffel Tower, and then you actually make the product layer by layer by using computational methods, by using material. There's a machine on the right, and at the center of the picture on the right is actual product which has been manufactured by a computational method along with the materials. So this is a layer by layer methodology as opposed to the subtracting manufacturing. For example, you have a machining process, you have a milling process, grinding. Compared to that, you're actually adding metal or adding material to create the part. So what are the industry applications? So let's start with the aerospace. The aerospace typically tends to have low volumes and very specialized applications. For example, the Mars mission or the Moon mission, there is only one of a kind which takes that part. Now, in these kind of situations, it is extremely important that you're able to meet all the requirements. For example, the high temperature requirements. The previous speaker spoke about we need to be sustainable. So how do we reduce the emissions? One of the ways is to improve better jet engine technologies. And for that, you need to have better fuel injectors. And that is made using additive manufacturing today. The next interesting area is coming because of the advent of electric mobility, propulsion, as well as land-based electric cars and automotives. So you're going to have electronics as well as consumer products which release a lot of heat, which need high performance. So those parts had to be made using additive manufacturing. The next emerging area is the medical industry. For example, the dental prosthetics or the orthodontics or the parts which are shown by my previous speaker, those parts which help the people who are physically challenged, they are all today made customized to the human being using additive manufacturing. There is also an emerging area of how can we make human tissues or tissues, human-like tissues, and those are called biomaterials. The questions of ethics and so forth are being solved, but in the future, this is going to be a reality which will improve the quality of human beings. The most prominent application today, with around 20% of the additive manufacturing industry, is in the area of automotive industry. Right from making the prototypes to specialized parts, the automotive industry has embraced additive manufacturing, and today it's becoming a more and more important aspect of the overall product itself. A very interesting development these days is about the construction industries. So you have heard probably of 3D printed houses, low-cost housings created in remote areas with exotic materials as well as fast manufacturing methodologies. So the civil engineering industry is also embracing additive manufacturing. You would not have thought or associated additive manufacturing with food industry, but you're right. There is also a trend towards using these kind of techniques to also embrace other areas like the food industry and the entertainment industry. Now, what is common to all of these is the fit, the form, the function, the user requirements. What does the user require? The best person who is able to assimilate all of these is very often the mechanical engineer. So the mechanical engineer becomes at the center of so many emerging areas, whether it is a medical industry. For example, you need to have a heart valve replacement. And that particular valve is probably made using additive manufacturing specific to that human being. And guess what? That material gets absorbed in the tissue after a few years. It doesn't behave like a foreign body anymore. It becomes part of the human body. How do you design parts which are having the physical strength, the reliability, and then becomes a part of the human body. These kind of challenges are today being addressed. So you can imagine that the additive manufacturing is poised to really expand into new chartered waters, uncharted waters, explore new areas. And this is just a representation of what I have shown here. Why is this so important today? Why do so many people talk about additive manufacturing? Why the session today? One of the reasons is this industry is growing on a base. 2020 basis was 13 billion, growing at the rate of 20% year on year. This is one of the fastest growing industries. Many of these patents which were there were for patents for additive manufacturing were in the years 70s, 80s, and 90s. So imagine a person wants to buy a machine or create a machine, they would be so expensive. But today, these patents are all now ready for people to be using because the average age is around 20 years. So those 20 years are completed. So it opens up entrepreneurship. A lot of entrepreneurs can start their own businesses using this particular, in addition, of course, to industries reducing their production costs. The next positive factor is superior computers. Cloud-based technologies and many advanced technologies have made computation very, very fast. And this is aiding the journey of additive manufacturing. Earlier, we would say, I trust welding or forging because it's a 100-year-old industry or 1,000-year-old industry. I trust it. But I don't know about additive manufacturing. Will the parts be strong enough? Will they break in life? Well, I can only learn probably by trial and error. But today, the emerging area of artificial intelligence and machine learning is telling the people who are into additive manufacturing what process will work best, which is the most energy efficient way of making parts. All these are being accelerated by the advent of machine learning. The next important thing for all of us to keep in mind that we are today at the center of the Industrial Revolution 4, fourth industrial revolution called Industry 4.0. The first one was the steam engine. The second one was the mass production of the automotive industry by Henry Ford. The third one was a CAD, CAM, CNC kind of machining. But today we are having the connected ecosystem where the manufacturing, the designer, the supply chain, everybody is connected, globally connected, and the parts are being manufactured, automated, manufacturing processes are being customized, flexible manufacturing systems. A lot of these are part of Industry 4.0, and additive manufacturing is going to play a very key role in the near future. Post-pandemic, what happened? We saw that many of the parts could not be imported. So many countries faced this situation where they had demand for parts, for example, personal protective equipment, or these days we talk about ventilators, but the parts cannot be imported because the transportation is not so easy. So people have realized that it is necessary to have local research and development and local manufacturing using additive manufacturing so that a short demand, short notice, locally I can source these parts. So the very supply chain, the manufacturing ecosystem in the post-pandemic world, people will start thinking differently at manufacturing, and that throws upon a lot of opportunities in this area of additive manufacturing. What are the related areas? Well, this is a very exciting space: physics, laser, optics, electromagnetics. So many areas of physics are connected here. You're also talking of chemistry, the material science, whether it is composite polymers or metallic materials, what are their properties? And people don't have data. This is a very new science. We have some data about powder metallurgy, but additive manufacturing materials, this is the very, very young stage of the industry. So there is enough opportunity to do research and also practice in these areas. The next emerging area, of course, all of you are aware, is computer-aided design. The next is process physics. How controlling the voltage or the current or the speed of these laser scanned material beams, how can I control the properties of the material? How can I make it more strong and less defects? So this kind of studies are today being possible thanks to the advancements that we talked about. And lastly, many of the mechanical engineers, core mechanical engineers in the past 15, 20, 30 years, they will say the heart of it was design for analysis, design for manufacturing, design for assembly. But today, a new area important for mechanical engineers, design for additive manufacturing. How do I design a part so that can be easily, cost effectively manufactured using additive manufacturing? So this is a very, very important field that is emerging today. And at the bottom, I can see that it needs to have fitness for a function, whether it is a heart valve or an aerospace component, whether it is strength, cost effectiveness, durability. The next thing below is very interesting. The mechanical properties, the strength, the weight characteristics, and the physical properties, whether it's the electrical conductivity and so forth. So many such areas are all together. What unites all of these? Core physics. So the mechanical engineer with the focus on physics related areas, the domain will be at a very strong position to be able to dictate the future of these sciences, whether it is manufacturing, use, and so forth. So it's important to realize that the software is important, and I'll come to that in the next slide, but heart of it is physics. So the mechanical engineer is by training very strong in this area, and I would definitely encourage all of you to look into some of these areas. On the right side, I'll say today where we are, wherever there is a need for customization, for example, a bicycle which is suited to me, the speed of manufacture and the complexity of the shapes, the most suitable candidate of manufacturing today is additive manufacturing. Some of the methods that I'm talking about, these are the four. This is probably my last slide. The stereolithography, selective laser sintering, fused deposition modeling, digital light processing, and many of these areas are all today amenable, and it's bringing down the cost of the parts. And earlier, we used to use only for prototyping, which was around 48% of the additive manufacturing industry. Today is prototyping, which means the parts which you can test. But it is going to be used more for tooling, and the end parts are also going to be made using additive manufacturing. So the trend will be more and more parts. The actual parts you use and will be having access to might be made by additive manufacturing. At the last line, you see the future will have more desktop 3D printers becoming accessible. Probably you will download from the cloud a program which can make a flower or a rose, and then you are able to print it at home, just like you would print it on paper. And industrial 3D printers, of course, that's going to revolutionize all the industries I talked about earlier. And at the bottom, you see many of the speakers emphasized again and again that mechanical engineers' life is no longer about the mechanical. They need to think electronics. They need to look software. And at the bottom, I've given 4 classes of software, 4 to 5, the design software, inspection software, the printers itself, the scanner, and the data analytics, which is used to improve the process further and further. So I can, in a summary, I would like to say that additive manufacturing has come a long way. More and more reliability is there. The cost and the efficiency is improving, and there are many factors in its advantage, which will, from 4 years from now, place it at a very competitive level compared to all other manufacturing methods, and in turn creates a lot of opportunities for mechanical engineers. Thank you.
Thank you so much, sir. Wonderful, crisp, and very informative session. Thank you so much. I now like to call the last speaker of the day, Mr. M.N. Guru Venkatesh, sir. Sir will be talking about the very much needed session, which most of the students, even before this session, were, putting the queries to us, is what happens to us post the completion of the program. So here is the answer to you, and over to Mr. Guru Venkatesh, sir.
Good evening to one and all. See, I think at the current situation, all of you know what is happening, and most of you are worried. Even parents are worried, and even most of the families are affected with COVID. And this is a part of our life. In going forward, I tell students to adjust to such environments and ready to face the challenging, challenging times. And another important thing I want to convey to all the students here: whenever the student comes to a campus, always they ask first question to me. They only come to placement office first. They don't go to even academic or admission department. How is the placement in the university? How many students got a job, and what sort of jobs they are getting? Always I tell students and parents, don't worry about jobs. Jobs will follow you. If you are skilled, definitely you get multiple jobs, and also the salary, how much you are looking, you will be able to get. On the screen, you can see skill level is not cheap. Okay, you can demand what salary you need. We have seen many students in Dayanand Sagar. They don't take up the job just like that. They demand what they want. They demand what salary they want. That is a message I want to tell from the day one. And always remember, those who don't study well, they will not be able to get a suitable job. They will get some job, but that is not highly paid and in a better company. Cheap labor is not skilled always. Okay. With this note, I want to take you through the important aspects of placements and other things. In the Dayananda Sagar University, we always focus on multiple things. My previous speakers addressed a lot of things. As a university, we don't only focus on academics, that is called art skills. We always focus on even soft skills. We train you on a lot of domains. I will share that in the next slide, what sort of soft skill training we provide and other things. Most of the industries, they prefer the students with multiple, means both the skills. I read in one of the newspaper long back, 70% of your success will go for your soft skills in an organization. If you are growing vertically in the organization, both you have to balance equally, and only such people can succeed vertically in the organizations. There are many students I have seen, they are very good in technical, but they don't have much of the soft skills. They will not be able to reach the leadership roles. If at all any organizations, give the opportunity for all of you to reach to the leadership roles, both the skills are very much essential in organizations. This is an interesting thing I want to share. The earlier days are gone because I've seen from last so many years in the placement department. Earlier days, just take 3 years back, companies were coming to the campus, they were recruiting students, and after recruitment, there will be a training for 3 months or 6 months or 1 year, depending on the organizations. Then they were putting into the jobs. But today is not like that. Okay, after completion of your graduation from the university, from day one, you should be productive. You should be able to work on the projects, and you should be, company wants to build from day one. With this thing, don't worry about the picture on the screen. Practically, don't be afraid. What I want to convey the message here is you must be job ready from day one. You have to spend a lot of time to improve your skills and learn a lot of new things. This is another interesting slide I want to share with you. Many students may ask me a question, or even parents. There are so many institutions in Bangalore we have. How Dayananda Sagar is different from other institutions? We always do different. Okay, as a university, as a college, we train students in different areas, different approach. We have a very good academic team. And if you see the diagram on the screen, first vertical, this is knowledge. That is regular academic, what we teach in the course. And if you see the second column, that is experience. Experience means we train the students using some practical component. Every lab will have a practical component, and students will be taught using practical component. In addition to that, we always train the student, as Chairman Sir Rajagopal Sir told in the beginning remarks. We have a concept of training students using projects in every semester. By end of every semester, students will be attached to a project, and they will be able to complete the project using the thorough knowledge what they have learned, and also what practical knowledge they have gained. This is one of the specialty of our university. By end of your course, most of the students will be eligible for the placements, and also will be job ready from from the day one after joining the companies. This is one of my favorite slide. Always I tell students, I got a chance to meet both the legends. I met Virat and also Kapil long back in one of the event. And we have spent a lot of time on this particular slide on the screen. If you see the Virat one picture, there are a lot of things comes to our mind. One is focus, dedication, hard work, commitment, everything will come into our mind. What I want to convey to all of you here is follow some good leaders. Don't follow the poor performers and not in the track. Those guys will not be beneficial. If you don't like cricket, I'm not asking you to follow Virat. You can follow Narayana Murthy or any other, good personalities. In the second slide, second picture, you can see Kapil. And in that event, Kapil asked all of us, you can ask one question to me. I got a chance to ask Kapil. I just asked him, what is success? How to measure the success? In a simple words, he answered to me, success is equal to talent plus commitment. And also he gave a beautiful example. He took an example of Vinod Kambli and Sachin Tendulkar, and both were childhood friends and played for Mumbai. And only Sachin can come up in a better way as compared to Vinod Kambli. And he beautifully articulated to this statement. Sachin was having both talent plus commitment, whereas Vinod was having only talent and he was not having a commitment. My message here is to all of you here, please focus on your studies, get a skill set, and also should have a commitment. Commitment in the sense completing the semester with good CGPA and also attending all the classes, follow your teachers, everything. All these things you have to maintain. Only those guys will be very successful during the placement cycle. This is what I was telling in the beginning. In Dayanand Sagar University, we always focus on a lot of things. From semester 1, we train students on communication and soft skills program. There are a lot of defined program for every semester that was shared from the employers. Actually, we have taken the inputs from the employers and accordingly we have fine-tuned our curriculum. Every semester we train some component, is value-added courses, additional courses, these are all. And also we focus on some of the niche technical skills. We provide guidance and support for students to get those technical skills. And also we have MOUs with a lot of industries for internship, placements, webinars, trainings, and industrial visits. We connect all of you to such industries during your course. And beauty here is we have a very, very strong alumni connect. Wherever you go, whichever company you go, you can find your friend. Your friend will handhold you. That is most advantage for all of you. That you cannot find in some of the colleges where if you could opt some of the colleges. Because we are having huge alumni base. Most of the companies, the top leadership from Dayanand Sagar. If you take Accenture, there is a top leadership, is from Dayanand Sagar. Like that, you can find in any organization. There is one senior most person in your particular department. This is interesting thing. All of you are waiting for this slide. How many companies will visit college and what sort of companies will come, what sort of salaries they give. We get at least 250 companies every year. These are an average numbers I'm saying. Sometimes even it will be more, sometimes in the same range we get. The highest salary, the last cycle, we got 31.5 lakhs per annum. And this will vary every year. Around 15 students got even international placements. More interestingly, I will share the next slide. This is what all of you are eagerly looking. What sort of mechanical companies will come to the college, for placements? We have very good connect with mechanical companies also. We work very closely with these mechanical organizations, companies. They visit us and also they are supporting us a lot. To quote one simple example here is we have Autodesk lab. We have innovation labs. The Autodesk set up the beautiful innovation lab in our university campus, where students are trained on industry level projects and concepts. Also, we have a lot of IT companies are visiting college. We have very strong connect with IT companies. To name a few, we have Infosys, Accenture, Cognizant, Tech Mahindra, and all. If you visit Tech Mahindra, there is a separate division called design engineering. There is a separate division called aerospace engineering. There they prefer to hire mechanical students with some basic knowledge of programming skills, because always it will work for them. If they hire only computer science student to work on mechanical project, it may not be sounding good for them, because they will not be knowing the concepts of mechanical engineering. That is the reason why even IT companies, they prefer to hire some of the mechanical students if they know some little bit of programming knowledge, not like computer science what they are knowing. You have to explore all these possibilities during your course. We will all guide you towards that. This is a total placement record in the college, total numbers. If you want to understand the total, how many students and how many offers are made. 2020 and 2021 are badly due to COVID. In spite of COVID, we could do excellent placements. Last year, we have done 2,241 offers. And this year, 1,889 we have done so far. We have another 2 to 3 months of time. Definitely, we will reach the same numbers like last year. This shows that what sort of engagements we have with corporates, and they mandate to come to Dayanand Sagar. Always they don't want to miss top-rated colleges to visit. If at all any slowdown, any problems, or any recession happens in the market, always they visit top colleges. They may drop to visit some of the bottom colleges. That is the advantage for Dayanand Sagar Group. We get almost all companies every year to visit. With respect to the percentage of placements at the university campus, Don't see the first column because that is only for MTech students. We had only 5 students, and most of the MTech students are going for teaching line. They only 44% of students opted for placements. And in the second 2 columns, you see last 2 years data. 75% of the students in campus, they got the placement. We got 190 companies visited. And last year we got 248 companies visited with total 81% of the students are got opportunity, means placed in the campus. These are statistics of the placement of the university campus last 2 years. These are one of the things I want to share with you. Most of the time, Samsung name, but we don't know what they started and what they ended. They explored all the domains and all the areas. What I want to tell here is, if you don't change, you become insignificant. That means that those who opt for mechanical engineering course is a beautiful program if you like to learn some of the new age technologies there. For example, robotics or some other domain like. My message here is many industries, they prefer mechanical, but some of the mechanical students, they only focus on old mechanical type of learning. That may not help. You have to learn some new things, programming skills, and such students will have high demand in the organizations. And this is another important thing. Please remember, all of you, you should have minimum CGPA of 6.75 every semester and every year to become eligible for placements. And normally the companies will not hire you if you are failed and supplementary you are taken and all. Year gap also they avoid. If you failed 1 year between and you are appearing for the exam and clearing, some companies may not prefer such students. And always should have some documents ready from now itself. Aadhaar, DL, passport, PAN card, whatever possible, you get it during these holidays after lockdown over. That is also one of the important things I want to tell, because I have seen many students, they come for the placement, they say, I don't have this document, I don't have this document. Then they will not be eligible for placements. And also, our Vice Chancellor sir was mentioning in the beginning, the current jobs will vanish. It is 100% true. We could see already 30 to 40% of current jobs are vanished. It's not there anymore. Okay, going forward, 70% of such job titles will vanish. We could see the new title will come up: data scientist, automation engineering, robotics engineer, design specialist, something like that. Okay, always demand for skilled manpower. Okay, don't worry about any other things. You become skilled, then you will be having a job. And another interesting things I am seeing today, whenever the companies are visiting, just 3 years back, they were offering the same pay scale for everyone, every student in the college. But now not like that. X company will visit the college, they see the students, and there are different set of assessments they conduct. If they do well, they pay them a very high pay scale. And average student will get middle, and low performed student get minimum pay scale. Start from 4 lakhs, and somebody may get around 8 lakhs, somebody may get around 12 lakhs. Like that they are offering nowadays. That is a new trend coming in now. That message here is the skilled one will get a better salary, better job, better profile. And not skilled one will get you have to compromise on the salary and also the job role. And also I'm seeing the trend of more online hiring happening now through social media, LinkedIn and other platforms. You should be very active in those platforms. For right things, you should always use. Don't use for wrong things, the social media platforms. You will be caught later. Okay. Try to market yourself in the social media with your achievements, your performance, what you have done. Then 200% the companies will be also watching. If you are highlighted there and things like that, and automatically you will get a message from the company, you have been shortlisted, you can appear for the interview process. And programming skills are mandatory for even mechanical students, core jobs. If you take a Tesla as a car, somebody was telling me today what is mean by car means software on wheels. There is no more car word we want to use. Car is nothing but software on wheels. The 70% of the car today with technology, either programming, embedded, sensors, automation, so many things are embedded in the car. Only 30% mechanical parts. I want you should explore all possible things. You should learn mechanical domain also. You should also learn programming side also. And there are a lot of platforms are available free of cost. They won't charge anything for the practice sessions. We have HackerRank, HackerEarth, CodeChef, and other platforms. Try to explore from now only. Even today, I have seen fifth standard, sixth standard students are exploring all these platforms. You must do that. Whether you join software division or not, that is secondary. But every profile today need programming knowledge. And majority companies are hiring towards internship based hiring. First they will hire as an intern, later they want to convert into full-time roles. This trend is increasing to measure your competency level. Suppose if you are joining a company for internship, if your performance is not good, then they will not continue for the full-time role. What is the message here is, skill is important. If you're skilled, definitely you will continue, you will do a good job during internship, and also your full-time job is confirmed. And this is one of the slides I will tell always students, if there is a will, there is a way. You want to do, you want to achieve, you want to take up, you will do that. Otherwise, it's difficult. Okay. And one of the teacher during my childhood told me two things. I still remember every day, every time. One is things will not come to us, you have to get the things. Always I follow that. We have to work hard and you have to get the things. Second one he mentioned to me is you are studying or working hard for your own survival, not anybody else. That is the second message I want to tell you to all of you. Please focus on dedication and go ahead with your plans. You will be successful. I think with this note, I thank you all of you for joining this session. I hope I covered all the points, so what exactly you're looking, and wish you all the best to all of you. Let us join hands to work together for a better tomorrow. Thank you all.
Thank you so much, sir. Thank you so much for giving the.
Thank you so much.
Giving all the details to the students. So with this, we move to the conclusion of today's session. And we would like to invite all the students who are interested, now that the exams are not going to take place and the board exams have been cancelled. We see a good rush coming in for applications, coming in for direct admissions, coming in for the DSET examinations. So you could always log in at the website given on the screen, dsu.edu.in, or you could call us on the numbers given. And let me also tell you that the first set of DSET examinations will be available to you. If you are going to apply before Thursday, you will be invited for these examinations, which is going to be online through a home-based proctored test. And that's where the selection process of the candidates will happen through this test. And there are 2 slots available on each of these days. So you can take the advantage of choosing the slot you want and go in for the examinations if you wish to come in through the DSET activity of ours. So thank you so much. A big thanks to all the speakers for today's session, and a big thanks to all the organizers as well as the students who have patiently listened to all of this. Thank you and stay safe. Thank you so much.
Yeah.